So this classroom is really, really far away. So that's why I have waited for 10 minutes. So let's start the lecture. So last time we have talked about the anthropogenic cycle, which would disrupt the natural cycle in our Earth system, right? We have different types of cycles. Okay. We have different types of cycle. For example, carbon cycle, oxygen cycle, nitrogen cycle, and also other elements. So in environmental engineering, we aim at study the disruption that we have caused to the environment, why we would be disrupting the cycle and how we can control that. So the engineering part would be about controlling that. So how do we control that? And last time we have briefly talked about the environmental properties of water and air, right? There are different examples in Hong Kong. So this is taken, this photo is taken in Hong Kong, right? We have talked about the red tide. So the questions that you need to answer is that if we can measure that before we can control that, right? If you want to control something, you need to measure it, right? And we are talking about science or engineering, right? There should be something that we could quantify, right? It's not just looking at the picture and saying that, okay, it's red. So how serious is that? Can we put a number on that? Okay. So another example. So it's odor is another very complicated problem because it's really hard to put a number on smell, right? Somebody might think that, okay, it's really smelly, and some people think that it's not, right? So how do we quantify that? So are there parameters that we can measure? So in this course, we will go into the details of that. Okay. So today we will cover the course outline. So last time we have covered introduction, right? What's environmental engineering? So next, we will talk about mass transfer. So it's very, very simple. It's like saving money in the bank. So we need to care about the input to the system and output from the system. So to put it mathematically, very, very simple way is that input is equal to accumulation plus output. So things have to be conserved, right? You cannot, so you have some gold coins here, right? You cannot find the gold coins to appear by accident. It cannot do that, right? It has to come from somewhere. So things should be balanced on the left-hand side and with the right-hand side, right? So that is the meaning of conservation of matter. So in the realms of environmental engineering, we study the materials balance. So to put it in a clearer way, in a more detailed way, is this equation. So let's say we have defined a space, for example, a lake here, or a power plant, or the air basin above a city, right? We have defined like an imaginary boundary, which is the dashed line here. So we study the input, right? So everything has a source, right? The source is the input. And then that would be equal to the output rate, decay rate, and the accumulation rate. So the sum of these three, because your substance can turn into other things due to chemical reaction. So that's the decay rate. And also your substance, for example, here I'm using sulfur dioxide as the substance. So it could be accumulating inside your system. So they should be equal, comparing the left-hand side and the right-hand side. So we'll get into the details of this. So what's the actual number behind this equation? The actual number is the mass flux. We have talked about this, right, last time, the concept of flux. So in this course, we don't care about the surface area that your material is going through. We just care about the total total amount. So total amount of your pollutant going into your system per second. So the flux into X here, this is the unit that we need. Kilogram, not just for air, kilogram of your pollutants per second into your system. So here, the unit of input and output should be kilogram of something, input and output in 1 second. So if you have forgotten this, please refer to the concept of flux. We had a slide for that. Okay, so you have a system and there are inputs of pollutant, kilogram per second, and then output, kilogram per second. Okay, and we care, why do we care about this? We can turn that into two terms. The flow rate can be the multiplication between the volume of the input. So the air that is bringing the pollutant, right? The pollutant cannot be going in a vacuum way, right? It is embedded in the air. So the air is entering, so these three boxes are entering your system alongside with your pollutants. And another thing is the concentration of your pollutants. So how much of the pollutants you have in one box. By one box, we're talking about 1 unit of volume. Your 1 unit of volume is 1 cubic meter in here. Okay, this is one box. And if you multiply them, you will get the total amount of your flux, or we call that the flow rate. Okay, so this is the unit for the equation that we had in the last slide. So we'll get into details for in lecture 2 about this. Okay. So lecture 3 would be about energy transfer. So we cover the first law of thermodynamics, pretty basic. So we know that the energy cannot be created or destroyed, and they can only be changed in the form. So the chemical energy here in the fossil fuel is turned into electricity through the power plants. Okay, so why do we care about this? Because you need to calculate how much you're polluting the environment per unit of energy you're producing. So if you're having a really efficient system, then you use the same amount of energy, but you pollute less. Okay, that's already environmentally friendly, right? So that's why we care about this, the energy that we can generate through different processes here. Okay. Okay, so to put that in math, the first law of thermodynamics should be about conservation of energy, right? So I put that in a cartoon way so that you would understand that pretty easily. Okay, on the right-hand side, we have the net change of energy. So if your system is gaining or losing energy, okay, and that would be equal different things on the left-hand side. So the first thing is the total energy crossing the boundary as heat. So pretty easy, right? So if you are heating up this bottle, then you're giving heat to the system. Or let's say if your bottle can expand or contract, then it's doing work or having work performed on that. So that's work done on your system. Or the third one would be matter bringing the heat into your system or out of the system. So we usually don't care about these two because we assume there will be no matter crossing the boundary most of the times, okay, unless it's your pollutant, okay. Okay, we also have to know about the radiative transfer of the Earth system. So this is like an average condition for all the points over the Earth. So the average condition for energy budget. So by energy budget, we are of course talking about energy coming from the sun, which is the orange part here. So the total energy coming from the sun, 341 watts per meter square. Some of it is reflected by the clouds, some of it reflected by the surface of the Earth, and only 161 is absorbed by the surface and 78 absorbed by the atmosphere. So on the right-hand side, it's much more complicated. It's what's happening on Earth. Okay, so the Earth is radiating at much lower temperature comparing from the sun. So they have like a different budget on the right-hand side. So the light orange part here is called the long wave radiation. It's the frequency that is associated with the temperature on Earth. So it's radiating through the atmosphere, but not all of it is going through back into space. Some of it is absorbed and reflected back. So this is what we call the greenhouse effect here. We need the greenhouse effect. It's not like we don't need the greenhouse effect. We don't need the human enhanced greenhouse effect. So if we don't have the atmosphere on Earth, what would be the temperature? Comparing to some planets like Mercury or other planets that is without the atmosphere.如果我哋冇大氣層，知唔知會幾多度啊？地球上面 Okay, it's around minus 18 degrees. So if we don't have our atmosphere, none of us would be here. Okay, of course we cannot breathe, but the temperature will not be good for life. Okay, because there's no liquid state of water and there would be no life. Okay, so there's a very, very special part in here, which is not radiation actually. So this very, very special part. First of all, the thermals part is talking about sensible heat. So the heat that you can feel, that's the sensible heat flux. So it's not through radiation, it's maybe through convection or conduction. Air is not a very good conductor, but there should be some convection. By convection, we're talking about actions associated with rainfall, right? Clouds, rainfall, things like that. And also we have evaporation. So the water is evaporated from the surface. Transpiration is actually two processes. One is the evaporation and the other one is water coming out from the plants. Okay, they are doing the transport of heat to the atmosphere also. Okay, so here, why are we talking about these two? They belong to different parts in the light spectrum in here. Okay, so next we talk about the chemical basis of our pollution problem. So there are different things happening, different chemical processes happening in our atmosphere or in different parts of the world. So for example, here we have acid rain because we have released some gases that would combine with the rain, okay, and then make the rain acidic. Okay, or we have the ozone hole problem. The last I have heard is that the ozone hole problem is actually improving a lot, so it's much smaller. That's because of some policy we have. We cannot use the products that would release the chemicals that destroy this ozone hole, so it's growing back. Oh no, the ozone hole is becoming smaller and smaller. Okay, so of course, the greenhouse effect, because we're changing the chemical composition on Earth. So that's why when we talk about environmental problem, we cannot avoid to use chemistry, okay? So this is like a revision. I think if you have taken DSE chemistry, I think you have already learned this. So stoichiometry is just a fancy word for doing balancing in your chemical equation in here. Okay, balance your chemical equations. I will go through the basics. So if you haven't studied chemistry, it's fine. Okay, and then we'll talk about the units, the mathematics that we need. So this is the concept of moles. I think I won't get into details. So we'll talk about this in lecture 4. Okay, so how do we deal with different chemical reactions? So here we are using the concept of chemical equilibrium. So in the environment, we assume that things would be in equilibrium, right? So even we can find different compositions in an area. even if they have continuous chemical reactions, we assume that they are in chemical equilibrium. It means that the things on the left-hand side would be constantly changing to the things on the right-hand side and the other way around. So they would be in balance, and we would study the math associated with that. So there's a constant describing this equilibrium situation, okay? The constant can be called ionization constant or solubility product, okay? So it describes, for example, here, if you put some salt into the water, it would be separated into positive or negative ions, and we can use some numbers to describe the equilibrium inside this water bottle, okay? So we'll get into the details in lecture 4. Okay, and lecture 5 would be, so it's pretty, the topics covered in this course, this is an introduction course. So the topics covered in this course would be very different, okay? So this lecture would be about mathematics of growth. So why do we care about growth? By talking about growth, for example, here, if you want to treat your wastewater, last time we have talked about this, right? It's illegal to wash your car on the street because on the street, you only have the drainage system for rainwater, which means that they shouldn't be polluted, right? So in the wastewater treatment plant, sometimes we use microorganisms to solve or to reduce the pollutants inside the wastewater, right? So we need to expect or we need to calculate the growth of this bacteria so that we can know how much wastewater we are putting into the plant every second. So this is actual problem we need to solve if you are an environmental engineer. Okay, so here on the right-hand side, we have another predictions for the future. For example, we want to foresee how much CO2 emissions we are having in the future so that we can know how to deal with the climate change problem. So there are different scenarios, just like you are projecting your future career where you have some ideas, but you don't exactly know your future. So you have prepare for the worst and then you expect for the best here. So there are different scenarios in here. So how do we deal with the growth? So this is like the simplest version. So it's like saving money in the bank. So every year, so this is not about putting in money every year. This is about putting money just one time. Okay, you have the initial amount of money putting into the bank, and then you want to foresee how much money you will get after a few years. So this is talking about the growth every year or exponential growth. So this is the mathematics is pretty simple. So the current year here, you will have some increase, some portion that the bank is giving you back as interest, right? And then that would be your amount for the next year if you add them up. So the second term on the right-hand side is the interest, right? Like a 本金同埋你個利息. Okay, wait, if you add them together, that would be your total amount for the next year. So which means that you can project forward 1 year by 1 year, and then you can calculate the amount after some years. Here, turn that into a general form. Okay, we'll get into details of that. Okay, and lecture 6 will be about risk assessment. So I'm no expert in risk management, but this is just talking about probabilities. Okay, so we need to deal with this because if you talk about air pollution index that we're using in Hong Kong, actually they are using this concept. How many people are getting into the hospital every day because of the bad air quality? They use that data to design the air quality index that we're using today. Okay, so we need to learn about this concept. So we need to, if we need to talk about different influence that the pollutants are affecting our bodies, we need to talk about, we need to have different categories, different types of hazard. So what are the different types? It could be acute toxicity. So the bad influence is coming really, really rapidly. So you are breathing in very bad air. And I don't know if you know about this. I have watched the Netflix series, The Crown. They have talked about this in the TV series. So a few thousand people die actually within the period of weeks. Okay, that's acute. So that's really rapid response because of sulfur dioxide. So you can see how polluted it was in London in the 1950s. Okay, so another influence would be affecting your genetic material, mutagenesis. So all the things that you're taking in, all the things that you're breathing in, so it could be affecting your genetic material or other systems in your bodies, and that could lead to sickness, right? So we need to separate them into different categories in order to study them. So, or they could be carcinogenesis, that carcinogenic here. So different types. So how do we assess the risk? As I was talking about probability, so we are talking about the relationship between the toxic substances, how much we are exposed to something, and how sick we are. How do you quantify how sick you are? We can, right? So in order to quantify, so that's the next slide, sorry. So in order to quantify how sick a person is, we are using probability. So on the x-axis, we have the dosage. So how much you're exposed to the pollutants. And the y-axis is the unhealthy response. So we count the people, how many people are exposed to something and how many of them get sick. So this is a percentage, right? It's telling you maybe they are giving you a linear relationship, which means that the more exposure you are having, more people get sick. Okay, that's the line here. Or you can have like some nonlinear relationship in here. So if this line is not straight, it could be nonlinear relationship. Okay. Nevertheless, if we have this relationship, we can find out the probability of getting sick due to a certain exposure, right? You know that, okay, if I'm exposed to this amount, how many percentage of chance, how large is the chance that I'm getting sick? So this is the graph that would help you to do that, okay? So let's go back, okay? So what should we do? We should do some controlling, right? It's environmental engineering. So we need to do filtering, cleaning. Maybe we want to set up a cleaning system so that the water, it has been treated. So that's what the Japanese government is calling the radioactive waste these days. They said that the water is treated. Okay, so you have treated the water and then it becomes clean, so-called clean. Okay, so but we need to ask the question is how much water we want to spend. Okay, if you want to spend a lot of money, on that, and then it's becoming really, really clean. But is it necessary? Do we have like a minimum or maximum amount of pollutant we can release to the environment without affecting a large population? So we need to do the balancing. Should we spend less money so that we can control the pollutants to a certain level? Okay, so this is what risk assessment is about. Okay, so next we talk about the water pollution problem. So I think I've already talked about this. So the circulation in the environment, the hydrological cycle in the environment, and when we release the toxins into the environment, it will go through the cycle. Okay, so that's why we are getting a lot of different chemicals that we don't want. Even when you want to, maybe you can collect rainwater and then you think that, okay, I boil that and it's totally natural, but it's not like that. Okay, it's already containing something that we don't want, some human-made chemicals. Okay, So it's very important because we need safe drinking water. So there are different types of water pollutants. So how do we quantify? Let's go back to the question. How do we quantify the water pollutants in the water bodies? So there are different types. The first type would be microorganisms. So we usually measure the amount of E. coli because it's easier to do the measurement. And we expect that if the amount of E. coli is high, other forms of pathogens would be having a higher amount. Okay, that's our hope. Okay, that's like an index, right? Okay, so next is nutrients. We don't want a lot of nitrogen, phosphorus, because that would cause excessive growth of some aquatic plants. So the picture here is showing that we don't want that because it's favoring some organisms over other organisms, upsetting the ecology. Okay, so next is oxygen demanding waste. So whenever you are throwing something that is eatable into a water body, that would cause a pollution problem, even though you think that, okay, it's not toxic at all, right? But it's using oxygen in the water body because when it's decomposing by the bacteria is using the oxygen. So it's not good. Okay, that's the third kind. Okay, so that's why we usually measure the oxygen level in the water to assess the water quality. Okay, so there are also other different kinds we need to do the measurement. For example, salt. We don't want that because we don't want the salt to go into the agriculture or in our drinking water or in our irrigation here. We don't want that. And also we don't want heavy metals. That's why we need the measurement. It's really, really hard to get rid of the heavy metals in our bodies. Okay, so next is pesticides because it's easy to go into the water bodies because we put a lot of pesticides in the agriculture industry. Okay, so how do we deal with that? We expect a certain kind of pollutants in our wastewater, for example, wastewater, and then we build the wastewater treatment plant. So coming from our homes and coming from industry, the water should be coming from these places, and then they should be treated before they are released back to the environment. And for the water treatment plant, so this is the left-hand side here is for the drinking water. It's not the same as wastewater treatment. So both of them require treatments, but they are not. The processes would be similar, but they are not the same type, of course, right? So it's the same, but maybe for drinking water, we also need to take samples and then do measurement with that sample. Okay. Okay, so this is like a very brief summary on how we treat the water. So different mechanisms to clean the water. Usually we put in the wastewater and then we put something in to have the impurities to stick together. Why do we need them to stick together? When they are stick together, they can sink to the bottom, and then we can collect that wastewater sludge. This is called sludge here. I think we have a facility doing that in Hong Kong. It's called Tea Park. They in that tea park, I think they burn the sludge to get the energy. 可以做 spa 嗰度有冇聽過？喺屯門好似冇啊。Okay, we do have such facilities in Hong Kong. So this is showing you Taiwan water treatment plant. And this is just a simple diagram showing you how the impurities can be stick together, right? Maybe through chemical processes. So we put a lot of positive ions so that originally the repelled impurities can be stick together, or we can put in some fibers here, very, very small fibers with positive ion, and then they would be sticking together. Okay. And in environmental engineering, we need to calculate how much wastewater we are pumping in, how much time we need, right? How much setting time we need the wastewater to be sitting inside this water treatment plant. Okay, so next we would be talking about air pollution problem. There are different types of pollutants in air. So there are primary pollutants. I won't go into the details. So they are directly released from the sources. And there are also other pollutants here. They react with something else in the atmosphere, and then that would create other types of pollutants. Okay. Also, of course, we do have the natural sources, but the things that we would like to control is, of course, is coming from human beings, right? So that's why if you have a car, you need to take that to do a checkup every year. They're checking the pollutants coming out from the exhaust in here. Okay, so how do we control air quality? We actually have regulations, or we actually have legislation, the law, to control this. So how do we control that? We have some objectives we want to achieve. So let's say we want to have like a minimum not minimum, the requirement for having this kind of, so we're not saying that we won't release the air pollutants. We're saying that we would release it under a certain amount. Okay, so this is the requirement. So for 2005, they expect to release the PM 2.5 lower than 15 microgram per cubic meter. So this is like the average condition. So if you want to have a better air quality, you lower this maximum allowance, right? So you lower to a certain level so that you think that you can control the air quality. Okay, so this is how we put that in law. Okay, so in the US, they started this in 1960s, I believe. So they have the first law in the world to control the air quality. It's called the Clean Air Act. So they actually put in the law so that the EPA, the Environmental Protection Agency in the US, they would do the monitoring and controlling of the air quality. So that's why we have different stations in Hong Kong to do the measurement to see if we're doing a good job. Okay. So next, we talk about the environmental impact assessment briefly. So 有冇聽過環評啊? That's the English, okay, environmental impact assessment, EIA. So we would like to, in the EIA, we would like to predict the environmental impacts of some projects. By some projects, of course, we're talking about the constructions of different things, constructions of some buildings, construction of some infrastructures, and we predict what kind of problems we have. For example, if you have a construction here, we might have some noise, right? And we might want to do something to contain the noise, right? Or we might have some pollutants coming out from this construction. So what we want to do is to control, right? Maybe we would install some boundary around this construction site so that the dust or the air pollutants won't travel too far, right? So this is what the EIA is doing. They predict the impacts and design the measures to avoid or minimize the problems. Okay, so we are trying to reduce the problems here. That's what the EIA is doing. Okay, of course there are different types of aspect. Also, water pollution. We also need to care about that, not just noise pollution and air pollution. Okay, so the last lecture will be about solid waste treatment. So every day we throw up something, right? We couldn't spend, we don't spend any time thinking about these things. So throughout your life, how much of the waste that you're throwing out. So this is how we deal with the waste problem. So this is how we manage the landfill. There's no open pit. What does it mean by open pit? An open pit is just a pile of rubbish, right? So this is actually, we haven't been improving throughout our human history. So in the Roman days, how did people deal with their waste? They just throw that in their homes. And then how they deal with the waste after that, they look for some soil and then cover their waste in their homes. So that's why archaeologists could find a lot of different things in the homes of the ancient people. So this is how we deal with waste these days. It's just in a much larger scale. We're not throwing the waste inside our home, okay? But it's the same, right? We have different cells in here. We have some rubbish in here, and then we put on a very thin layer of soil to cover the smell, and then so on and so forth. And this thing, we have to put them in a stacking style in here so that it won't collapse, okay? So there's only so much waste we can put on the land. So one day our landfills will be full. So that's why our government is having the new policy to charge us for the things that we throw away, okay? So this lesson would be about that. So how do we have a sanitary landfill? Okay, today we don't have tutorial. Yes, we don't have tutorial for the first week. There's no calculation. Or you, 你係咪想做功課啊？今日？Yeah, you can leave now if you don't have questions.